All right, let's dive in. We hear about AI doing these incredible things pretty much every single day, right? But have you ever stopped to wonder what's actually going on under the hood? How does a chunk of code go from knowing literally nothing to mastering a language or spotting a cat in a photo? Well, we're going to pull back that curtain and take a look inside.
So, what is it? What's the engine that actually lets AI learn? And look, I get it, it totally feels like magic. But it's not. It's actually a brilliant and totally understandable process, and we're going to break it all down step by step.
So, it all kicks off with one single fundamental problem that every learning system, human or machine, has to deal with, and that's uncertainty. At its absolute core, machine learning is just about making sense of a world that is messy, incomplete, and, pretty unpredictable.
Okay, so to get a handle on this, we first need a language, a way to talk about uncertainty. And that language, well, it's the language of probability.
So probability is what gives AI this structured way to deal with all that unknown. It's basically a framework that lets a model put a number on what it knows, what it doesn't know, and exactly how confident it ought to be about its predictions.
Now, this is a super important distinction to make, the difference between probability and statistics. See, the probability of getting heads, that 50-50 chance, that's a theoretical thing, right? It's a property of the coin itself. But when you start actually flipping it, the number of heads and tails you see, that's a statistic. It's real data you observed. And the whole goal of learning is to use those statistics from the data to get as close as you possibly can to the true underlying probability.
And this right here, this is the law of large numbers in action. Look, after just 10 tosses, your estimate could be way off. Maybe you got 7 heads, who knows? But as that model sees more and more and more data, we're talking thousands of flips, its estimate gets closer and closer to that true 0.5 probability. This is so fundamental. More data literally reduces uncertainty.
Okay, so our AI now has a language for uncertainty. Cool, but how does it actually use that and all the data it's seeing to learn anything? Let's get into how that process is really built.
It all boils down to this simple but incredibly powerful loop. First, the model makes a guess, a prediction. Second, it compares that guess to the right answer and measures how wrong it was. We call this the error or sometimes the loss. Third, it tweaks its own internal settings, its parameters, to try and make a slightly better guess next time. And fourth, it just does that again and again and again, millions or even billions of times.
But hang on. Here is the multi-billion-dollar question, right? When the model adjusts itself, how does it know which direction to go? Out of its millions of little knobs and dials, how does it know which ones to turn up and which to turn down to make that error smaller? I mean, guessing randomly would take, forever.
Well, the answer, the secret sauce that makes this whole thing work, it actually comes from calculus. It's a concept that gives the model the exact direction for improvement. This is the magic right here.
And that secret is the derivative, or what we usually call the gradient in machine learning. And you can just think of it as the slope of the error. For every single parameter inside that model, the gradient tells it two things: which direction makes the error go up the fastest, and just how steep that slope is. So to get better, the model just has to take a tiny step in the exact opposite direction.
I love this analogy. Imagine you're a hiker and you're blindfolded, standing somewhere on the side of a huge valley. Your goal is to get to the very bottom, the lowest point. How would you do it? Well, you'd feel the ground with your feet, right? You'd figure out which way is downhill and you take a step in that direction. That feeling of the slope under your feet, that's the gradient. The bottom of the valley is the lowest possible error, and the model is that blindfolded hiker, just using the gradient to find its way down.
Now you might be thinking, okay, I could probably calculate that for a simple problem, and you'd be right. But, like the source material points out here, for the kind of gigantic AI models we use today, trying to calculate all these derivatives by hand is, it's completely impossible. It'd be tedious, full of mistakes, and it just wouldn't scale. Not even close.
So if we can't do it by hand, how on earth is it done? This is where the real engine of modern AI finally comes into the picture. It's a technology called autograd.
Automatic differentiation, or autograd for short, is the system that's baked into every single modern AI framework. You've probably heard of them, like PyTorch or TensorFlow. This system does all that heavy lifting for us. It automatically and perfectly calculates the gradient for every parameter in the entire model, no matter how ridiculously complex it is.
I mean, the difference here is just, it's night and day. Doing it manually is slow, error-prone, basically impossible. Automatic differentiation is lightning fast,
perfectly accurate, and it is the key piece of tech that makes these huge, modern AI models even possible. Without this, let's be clear, the AI revolution we're seeing, it wouldn't exist.
So how does it pull this off? Well, as your data flows forward through all the model's calculations to make a guess, AutoGrad is quietly building this map in the background. This map, we call it a computational graph, keeps a perfect record of every single math operation and exactly how each number depends on all the others.
Then, to do the really clever part, it uses an algorithm called backpropagation. It starts at the very end, with the final error, and works its way backwards through that map it just built. As it goes, it efficiently figures out the exact slope or contribution of every single parameter to that final error.
And you know what's kind of wild? This tech isn't even new. The core ideas behind it, behind backpropagation, they've been around for over half a century. It was really the recent explosion in raw computing power that finally unlocked the insane potential of this decades-old algorithm.
All right, let's put all these pieces together. Let's see how these big ideas combine to actually create artificial intelligence.
So let's just walk through that one more time. An AI has to navigate this messy, uncertain world, and it uses the language of probability to do it. To learn, it follows a simple loop. Guess, measure the error, and adjust. The gradient is its perfect roadmap. It tells it exactly which way to adjust. And finally, AutoGrad is the automated engine that calculates that gradient, allowing this learning loop to run at a scale we could never, ever do by hand.
And when we talk about scale, we really mean it. A model like GPT-3 has 175 billion parameters. Can you even imagine trying to find the right direction to adjust 175 billion different knobs all at once by hand? It's unthinkable. AutoGrad isn't just a nice-to-have. It's the fundamental technology that makes modern AI possible, period.
And that kind of leaves us with this incredible thought, right? We have successfully built and automated the very engine of learning itself. That core process of getting better, of improving, is now basically a solved engineering problem. So the real question isn't how machines will learn anymore, it's what do we, their creators, choose to teach them next. Thanks so much for joining me for this explainer.